Hello. Let's talk about some issues regarding performance. The session was named Turbo Firebird. Turbo Firebird is the idea behind that. We simply have the possibility to improve the performance of a Firebird server with some technologies which are in one side available due to additional software, in other parts available due to changes of your hardware. And in the last years, especially the hardware part has changed a lot for database servers. We have still a dual processor Intel-based computer in our office, somewhere standing in the corner. I think it's 9 years old or so. It was really expensive in that time, but it has 2 real CPUs. And nowadays, it's not a big deal. For example, I think an AMD 6-core processor costs about $300 or something like this. So it's not a big deal to buy multi-core applications. And I think a few days ago, I read a description of a computer which had 4 CPUs with each 6 cores, so 24-core CPU server. And the price with really fast hard disk rate was, I think, €3,000 or something like this. And it's already a really cheap thing if the first 24 users have their own CPU core that can be used on the server side. But one of the major things that should be considered when you think about improving performance is simply have a value to measure performance. And a value to measure performance often means to have some benchmarking program or whatever. And whatever a benchmarking program will test for you, it might not help you in your specific project. When you have a very slow graphic unit, for example, it might decrease the overall power of your system, even that the I/O subsystem can be already very fast. I prefer to have a speed test based on Firebird when I want to measure the speed of Firebird. And this is one of the demo database that we have also included inside the IB Expert package. There will be a new release of this demo database within the next release of IB Expert. But you can find it already in HK Software IB Expert DemoDB. There are simple scripts. The DB1 script, for example, creates a small database with some really simple operations. Insert some data, and the data inside this table I call a specific procedure. Okay, now the database is almost empty, and this database is currently running on a Firebird 2.5 server, and the database itself has some small tables inside. For example, a customer table, which has some data here, but no data inside. No records are currently inside the database. A product table. Product table is, for example, here. No data, but different columns with foreign keys to other tables and so on. The idea behind this database is we have inside the database temporary tables. They are only called TMP tables. It can be used for any other platform also. It's no change to a really table. And we have some data, for example, we have some first names. And we simply have here a list of first names, 600 and whatever first names and last names. And the idea behind this database is really simple. I took the data from a US American church organization. They had a list of all their members on the internet, which is perhaps really nice for them that they are listed everywhere. But I only took the first names, I took the last names, and put them into a specific table. And what I do inside this performance test is really easy. I want to delete these procedures because they are not used. I think this one should also be not here. So the rest should be the original database with the next issue that we have. And I used this test already on a lot of environments from customers and so on. And I will talk about some results that I found with customers already in a few minutes. What we do to measure the speed of the database is really simple. We simply start this procedure, and this procedure does nothing else than deleting all the data inside all tables, which is a different procedure, set the generator to specific values, and now get some random data with a random function here that selects a first name from the first name table, a last name from the last name table, an address record from the address table, put all the data together, put in the country USA, because all people from USA have problems that there are other countries around the world. So USA people always think that data must be for USA, and all the rest, for example, people from Europe have no problem to understand that US people have different problems. It creates some email addresses, all are result at yahoo.com. It creates some phone numbers, some credit card numbers, and so on. And it also creates, in the next step, some product names. And the products inside this database is simply a demo database to create some demo data that can be used to display data, for example, for a fair or for product presentations. And especially, for example, in the medical area, it's not nice to have real data shown on such an event where you have, for example, the hospital history of one guy in reality on the screen, and everybody can read that. This is not a nice idea. What we have here inside is simply a title word. A title word is simply a list of words from a film database. So, for example, if you see here for a title word like butterfly, chaplain, and so on, a number of title words are simply combined to a new title name, and this should be represent a product which is a DVD. And the procedure here itself does a simple job. It simply creates data from the temporary tables with a lot of select statements and writes them into the static tables. And at the end, it takes from the static tables some data from customers, some data from products, and creates orders automatically. And what we do inside here is simply, when we start this procedure, we use a parameter which is named count, for example. And this parameter here in this way, for example, creates 10,000 customers, 10,000 products, 20,000 orders, and about 60,000 order positions. So when I run this, we have a lot of operations inside the database. And we can measure the time, how fast it is to run this database procedure on this specific hardware. So for example, I have now the result that everything was created within 16 seconds. And what you see here is an overview, a very helpful overview about what happened. I can go to the list of informations, which means simply on the table customer, we had 2 index reads and 10,000 inserts. On the table customer history, we have 5 index reads, 5 updates, and 35,000 inserts, and so on. And overall, we have about 850,000 operations. And an operation means, in this case, individual select operations, or insert, or update, or read operations. So you see that 850,000 operations within 16 seconds is not a bad number from my point of view. And this is a laptop with a Intel i7 processor, which is not as powerful as, for example, server processors like the Intel Xeon architecture. I've seen this test in the best time I've seen it until now in 9 seconds. It was one of the high-price Intel Xeon processors that are currently available inside a Dell server, which was extremely expensive, but it's still a good choice if you need the performance. What happened inside this procedure is really simple. As I said, we have created a lot of customers. Here's a list of customers. So overall, we have 10,000 customers here inside. We have data for orders, and we have data for order lines with relation to products and so on. And we have also some inventory information, for example, how many products have we still in stock from each product and so on. And this test, simply starting this init-all procedure, is a simple test to test the single core performance of your database system. The single core performance simply means I start this operation, I create 850,000 operations, I create up to, I think, 100 and whatever thousand new records inside several tables. And how many time does it take on your specific hardware? And the next operation that I test is this one. Create more orders. Create more orders means simply, I have now 10,000 records inside the customer table, and I have created, based on this database already, 10,000 orders, but I want to create 10,000 new orders. And this test, for example, especially the test create 100 orders and create 1,000 orders, is used for multicore testing environment, because I run this procedure from several clients. The clients can be on the same computer because the client itself does not have any impact of the major performance here. And what you have seen here is now the result that it took about 40 seconds. And within the performance analysis, you can see, for example, that on the product table we had 35,000 operations. On the orders table we had 45,000 and so on. So what we simply have available in this database when we are testing a database performance for customers, we simply use this database, create a database internally on the database server, first run the init-all procedure, getting the result, how many time it took for init-all, and then in general we start the create 100 orders 100 times, create from batch file. It's really simple. We use a IBA block script, which will be in the next edition of IB Expert for yourself also. You simply start one batch file, and it will automatically start 100 scripts on one machine that connect to this database and try to do this number of orders. And after that, you will see how many time it took to run all these 100 operations, where each created 100 orders. So this gives you an overview for about having an environment of 100 users connecting to your database. With this test, we also found out that the activity to really actively connect to the database and disconnect and reconnect and disconnect has some problems sometimes in this classic server architecture. Sometimes for whatever reason, but only on Windows, we have the problem that after 45 to 50 connections which were available, the Windows system declines to have new connections from new clients, and you get some problems to get onto the database under high load. So in some areas, the classic server has this issue in Windows. Might be sometimes not the best idea for having such a big test. But we found that on the super server we have no problem with that, but we see also that the super server will not use the individual CPUs. With the classic server, we see that the individual CPUs also get used by this test. So you will have a possibility to find out if it will be an advantage to have a 24-core database server as a replacement for your perhaps dual-core machine, which might be 2 years old or 10 years old or whatever. You will definitely find an improvement of performance. And if you have the possibility to have measured value that you can explain to your management or to yourself or to whomever, to your customer, that you say, okay, this database hardware has a speed of perhaps 100%, and when you switch to this database hardware, you have the possibility to improve the speed of the database itself, the internal database operations, for 100, 200%, for which amount of money. This gives you a nice decision environment to talk about investing in a new computer without only saying, I think it must be faster, and after you have paid for it 20,000 euro, you think it should have been faster, as I saw it. Especially the new architecture of some Intel CPUs with the turbo boost stuff is nice for the single CPU test, for the init all. But it will decrease in performance when you use the multi-user test. So for a single core operation database, I would recommend to use the Intel E7 architecture when you have not so much users on it, because they are not so expensive. But on really multi-user environment, I really would recommend to have a really Xeon CPU available with really fast operating, with really fast hard disk and I/O subsystem. We have already the experience. We have one guy here from Iran. He's experienced with a RAID controlling, with a RAID based on SSDs. So if we like, we can also discuss this a little bit later. I found an article somewhere in the internet where I cannot go now for whatever reasons. It goes. SSD, which is a really nice article. What some people tested, they simply had the SSD, the solid state disk. They have created a RAID based on solid state disk, and I think they have implemented 2 RAID controllers with each 8 SSDs in one machine, and they had I/O possibilities up to 2 gigabytes per second. And when you imagine that an S8 hard disk, the maximum, the physical maximum that might be possible is 300 megabit. It is extremely fast. And they have done some really exciting, really interesting tests about this. But for whatever reason, I will show it perhaps later when the internet is back again. What do you think, what happens inside a typical operation inside a database? This was one of the testing possibilities for you to see, to measure your own environment and to measure it comparable to others. We are interested in getting information from people regarding results. We want to offer a list of results. So if you have, for example, a specific hardware, please use this database with the batch files that we have in next ID Expert version. Simply run this batch files and simply send us the results. We want to have a description of hardware possibilities. For example, what are the advantages of using a 24-core AMD whatever style system with a 20 SSD RAID whatever construction? This is sometimes really interesting also for other people to know already when I switch from one hardware to another, what will be the gains, what will be the advantages of this environment. I hope so. We can have a look. I will present you some next step. The idea behind the number, which is 10,000 that I used, is really simple. When I initiate the first init all operation with 10,000, you get 10,000 customer created and so on. When you are using the parameter 100,000, you will get a much larger database, 10 times larger. The initial database with 10,000 has a size of about 29 megabyte, which is not so big for this amount of data that is already inside. But when you want to have, for example, test with a database with 10 million records, it makes no sense that you have only 100,000 records inside your database. So it's often a problem to create a database within the projected size of demo data that you need inside your application. And you can modify, for sure, every of this table or add additional tables to have, for example, product information from your product that your company sells or your typical customer will sell with your application. And you can directly create a demo database from inside database objects. What we found regarding tests that we made with this database, with Firebird, on specific hardware, switching from 32-bit to 64-bit. So means comparing 32-bit Windows system with a 32-bit Firebird on it, compared to a 64-bit Windows system with a 64-bit Firebird system on it, took about 15% less time. So it was 15% faster, or 20%, depends on the way where you set the 100%. It is really recommended by us that you are using 64-bit Windows and 64-bit Firebird when you can do so. One of the reasons why not using the 64-bit was often the UDF problems, but Christoph's library is available for 64-bit, and also there are possibilities, as I showed yesterday on Lazarus, to write your own UDFs if you need them. This database runs without any UDF, so it can be used on any platform where Firebird can be installed. So we also have found that using the same hardware for the test that we used for the Windows test, we've installed SUSE Linux on it with 32-bit. And we also installed the Firebird server on it with 32-bit. And we also installed afterwards, after we made the test again, with Linux 64-bit and Linux 64-bit Firebird. And we found out that the relation between 32-bit and 64-bit was almost the same, between 20% faster than the base of 32-bit. The switch between Windows and Linux was almost unmeasurable. We did not find a real way that one of them is faster. This was a little bit different when we used the multi-user thing. When we started from different Windows systems that we had in our training center, we started from 10 laptops, these batch files, to create 100 orders based on this specific hardware. In the multi-user environment, especially the classic server on Linux was faster than classic server on Windows. Super server on both platforms were almost the same. So the classic server on Linux has some advantages regarding multiple users, especially since the classic server on Windows sometimes get errors when you have a lot of connections setting up and going down again. But this does not mean that you cannot use also Windows in a multi-user environment really fast. But this can be used for a base of test, and you will get the script within next IB Expert version. It will be also in personal edition, but to measure the results, I think it's really useful to have the performance analysis and so on. So it might be a good idea to have the full version of IB Expert to measure and to compare the results in reality. What I want to show you also is talking about the technology of SSDs, solid state disk. It is sometimes already an improvement of speed when you're working on a single machine with only a hard disk, a solid state disk, as the disk for the database. Why does this happen? I hate the internet connection here, but I have to repair it in a few moments. I will take a different way. I will directly take over the telecom network. So everybody else will no longer have internet connection. Perhaps the hotspot does not work properly at the moment, don't know. So we have to stay here on my local machine. I wanted to have it tested last week, but I did not find the time already. But I will definitely test the Super Classic version with a hardware that we have, that we are using for web server, with a Intel i7 quad-core, 8-thread, whatever construction it is. And we will publish the result definitely as fast as possible. So it seems that the Super Classic has some advantages as far as I know until now, but I have not made my final decision about what I think about in reality. I simply want to show you some other things that should be considered regarding database performance. When you create a database, the database file will be created on your local machine. I think I have to reboot my computer to use it, but I will do it perhaps in a few minutes. What I want to show you is some simple think regarding functionality of the Firebird server when you are working on, when you are creating, for example, databases. What I've started here is a tool which is called the Process Monitor from SysInternals. Now a company owned by Microsoft, and it's really useful. And what I do now is simply, process name is FB_enet server. So simply want to monitor all the operations done by the FB_enet server, which is the instance of Firebird that is running on my machine. And we simply want to see what happens when I, for example, create a new database. tmp d1.fdb sysdba master key. Okay. It was filtered for whatever reasons. Process name is FB_enet server contains. Okay, now we have it. Okay, I register the database. And when I open the database again, these operations are done inside the database. And what you see here, for example, is I can add the options, select columns. Here you can monitor what happens when you are working on such a database. So when I simply start an operation, to make this a little bit more visible for you, I do not use IBExpert because IBExpert does a lot of things in the background, and it will often use operations that are not directly combined with the things that we need. I will go to C. I use my favorite tool. Okay, set ISC_user sysdba, set ISC password master key, and we simply connect to the database. ISQL localhost /51 tmp, and it was D1. D1.fdb. Okay, this is used already. These were the operations done inside the simple process of login to the database with ISQL. So here you can see some operations, for example, accessing the security database. The Firebird server itself simply goes to the security database and opens the data internally. And here you can see, for example, the basic information regarding the offset. So in which position inside the file this operation is searching for data. And the offset and the length internally, the details in this file, can be found, for example, offset 0, database header page. The first page size is red inside here. So here we have some operations. You can imagine here. Starting here, we have offset 0, go to the header, go to position 2 million, go to position 400,000, go back to position 2 million, go back to position 200,000, go back to position 1. the Firebird server itself reads and writes data always from the beginning to the end, to the beginning to the end. It has some functionality which is sometimes described as careful write. It has always some operations inside a sequence order that will result in having, when writing to the database file, also always a valid database file on the disk. But the problem, when you jump from position 0 to position 2 million and back to position 0 and so on, is that one of the most important times that you need for a fast database operation is the access time of your hard disk environment. So if you have a really fast hard disk with slow positioning time, it will be really bad for Firebird. Because of this construction, you always have several areas where the data is read, where the data is written, and so on. So what can you do in such an environment to improve the speed a little bit? One of the things you can do is really simple. You can simply create a shadow with a number and the TMP D1 SAD FBCon. Creating a shadow is really simple. There's one SQL command that you must start and now do the commit. And in the moment when you're doing the commit, now all operations, all writing operations, are not only done in the original database file, but also in the shadow file. So when I now go back and do, for example, a select count star from RDB $database, it does here some operations in the shadow, but most operations are done, especially the read operations, are only done in the original database file. So using a shadow can be, for example, be a nice way to have a original database created on a RAM disk and a shadow on a regular disk. Because a RAM disk has the fastest possible access time that is anywhere possible. A RAM disk typically is up to 1000% faster than SSD. And if you have the access time from the front to the end, to the front to the end, and so on, it is sometimes really easy to create your database also with high load on a RAM disk and have a shadow file only on the non-RAM disk, because in the case of a failure, you would otherwise have loosened all the data inside your RAM disk. But every writing operation is done in both files. But all the reading operations, RDB dollar, relations or so, all the reading operations are done outside the RAM disk, are only done on the RAM disk, on the original database file. So this shadow construction can be used if you are working with a fast CPU with a lot of database operations, and what amount of database operations you have, you will see typically here under real load, you cannot even use this protocol because this protocol gets extremely large. But you can, for example, do some filter, for example, set the process ID to a specific process only. When you are using the super server, the classic server, for example, each process instance has its own process ID, so you can monitor, for example, only one process ID. This construction and this overall functionality might also show you some of the things when you have a look at the Firebird server and think about what does it do now, and you do not even understand what he does in that moment. It is sometimes a nice idea to find out that the Firebird server itself, for example, writes a lot of data to a temp file or something like this. Yes. The problem, as far as I know, currently you have always limitations regarding the RAM itself. Most operations are done directly in RAM. And if you have, for example, a lot of database cache pages set in your database, it will be no problem to have most of the database already in RAM automatically. But from my perspective, every time when you're doing, for example, a commit, and you have force writes activated, you cannot only write in RAM, you have to write also on the hard disk. It is here the same. You have to write also on the same hard disk again. But in smaller databases, up to, I would say, 2 or 5 gigabytes, you will not see a difference. But your own database, for example, 500 gigabytes, do not know if you have 500 gigabyte RAM in your machine. Depends on the architecture that you have, but I doubt it's a little bit expensive currently already now to have 500 gigabytes of RAM inside a database server. But in general, this is only the option to work on a RAM disk is only one option. It will not get so many improvement of the speed as you might imagine now. It's not when you have 25 years ago worked with a DOS-based computer and you have chosen to write some data on a RAM disk. You had sometimes improvements of thousands of %. This will not happen with Firebird. Firebird is already really good programmed regarding the I/O operating system. But there are some operations which are always done on the hard disk. For example, one of the operations can be also seen really good here in the monitor program, writing temporary files. When you have, for example, a SQL statement that cannot use an index, you always have a sort buffer definition inside your Firebird config file. And when this sort buffer, the amount of memory that is used in the sort buffer is not enough, it will directly go to a physical drive into the temp directory and write their temp files. And these temp files can be, for example, created on a RAM disk, which is formatted, for example, with an NTFS compressed construction, with a compressed partition, for example. And using the same data in memory, there is no compression inside. So sometimes this improves the performance. We had a result from a database for German Telecom, where the database size was 45 gigabytes of size, and we had to make a report based on this database. And we were not allowed to use stored procedures for this report because they did not want, at that time, they did not want to have stored procedures in that database. So we decided to have a really long SQL statement to get the results with a lot of subselector and so on. And when I started this application, on my laptop it ran really fast compared to the amount of data that I had to get from this database. It took about 20 minutes and the result was there. I sent the same application to the customer. He started the application and 9 hours later he called us and said, oh, it's still not over. And okay, then you have to wait. Perhaps you have a really slow server. But 1 hour later they called us, the interface server at that time said, oh, I ran out of memory on my hard disk. And I looked on my laptop where I have developed this, and I had on my laptop 20 gigabytes free. And they had 50 gigabytes free on their machine. So we thought, where's the problem now? And I had a look at this operation with this process monitor open. And it created temporary files on my machine also. But I used in that time, I used a compressed NTFS partition. And the compression was really important because the temporary file was in the largest state 185 gigabytes. But due to the compression, it was only, I think, about 5 gigabytes physically on my machine. I talked to the guys at Telecom and they said, okay, we can do it in the same way, but we are not allowed to compress any partition. In that case, you have to buy a new hard disk. Okay, no problem. They bought a new hard disk. Next Monday, the hard disk was built into the server, and the same operation took, I think, about 3 hours. Because when you're writing and reading 180 gigabytes into a temp file, typically it is not a one-time write into the temp file. It's sometimes really interesting to have a look at the task manager, how many data was written and how many data was written or read it here. So sometimes you see that reads a lot more data than you expect. And in that case, you should perhaps think about using, for example, the temp directory not on a non-compressed partition. This depends definitely on a lot of issues. So it depends also on the number of database objects that you have included in this environment and so on. Our testing regarding this, using a database on a ramdisk and using the same thing with a shadow on a regular disk at the same time. The best performance advantage was on one server, was a Xeon server, was 80% faster. So it was not bad, but it was not a revolution in my point of view. Because in most cases, it depends on what you are doing in writing operations. When you are doing a lot of writing operations inside the database, you will perhaps already lose some performance because you have to write it twice. But if you have a lot of reading operations, it might improve your performance. But depends on the ramdisk manufacturer, on the software that you're using for the ramdisk. I've used the testing with a product from a company which is called DataRam. I cannot show you now, but simply have a look at DataRam, Google, and you find a manufacturer of memory modules. And in that time, I think I received the ramdisk software for free, but I think the ramdisk software needs to be paid for $10 or so. You have the possibility to set up a ramdisk up to 64 gigabyte. So it's sometimes really nice to have a really, really fast environment. But there are sometimes also some disadvantages working with ramdisk. So it's not a solution for everything. I would really like to have shown you the SSD report, SSD on steroids. I will definitely give you a link where you can find it. It's really funny to see people with an open desktop server having all the cables around and having eight SSDs on each controller with 2 controllers and defining some testing compared to other architectures. So it's extremely fast. And I think it was a solution to, nowadays you have to pay for such a construction about $10,000 or so. This would be the investment, how you can get already such a solution. My personal experience with SSDs are divided into several experiences. Some are extremely bad. I had a SSD in my laptop, and from one day to another, I had no more working laptop. And it was even impossible to recreate a partition on my SSD. I had to send the SSD to the original manufacturer, and it was sent back, and it worked again. They had some tricky software to recreate the partition on it, but I was not able to create a partition on it already. Since I lost already data in that time, it was not a nice experience in that moment. So SSDs in some areas are really interesting when you think about working with SSDs in your machine. OZZ is a good manufacturer, and Intel is an extremely good but expensive manufacturer of SSDs. The Intel has 2 series of SSDs. The M series is nice, but not so fast and not so reliable. The E series is extremely fast, extremely reliable, and extremely expensive. I think a 64 gigabyte RAM disk, you have the price of about €1,000. And depends on how the speed improvements are based on your machine. The database functional speed, when you are working with VMware, for example, was a decrease in our experience of about 20-25%. So if you're simply using with a database server on a VMX server or whatever, you lose about 20-25% of the overall speed if you compare it on the same hardware without a VMware. But it is still, for a lot of cases, the better choice. For example, I really love to have a VMware, for example, on our web server, since when our hardware goes down, I simply copy the VMware from one disk to another, and I can restart it without any configuration tasks and so on. So the virtualization goes more advanced every year now, and will be definitely a part of the future. I would really like to have access to the remote server where I can show you some operations with the same database on the RAM disk. I cannot do it now, But since you will get the database file itself right after the conference or in the next IB Expert package, you can do your tests also on your own machines, and we are really interested in getting results from you to find out perhaps what is the best hardware that any one of us has under his control. A customer of us is working, it's a hospital in Freiburg in southern Germany. They are working with Firebird servers on so-called SAN, storage area networks. And it is extremely fast. They have an extremely expensive system. They do not, when I was there, they only knew that the Firebird server is working on such a SAN, but they did not know what was the manufacturer and what was the price of it. They know that the price must be somewhere in the higher six-digit level, so almost 1 million euro. It was really expensive, but it is in use for the whole hospital software, for everything that is running in the hospital there. And it's extremely reliable, it's extremely fast, but extremely expensive. So it works really nice with Firebird, but in some cases you have to think about the same problems as everywhere. Do not even think about deactivating forced writes. You never do this. We had, for example, currently a problem with a customer in Netherlands who deactivated forced writes and who was writing his database file on a SAN, on a storage area network environment. And part of the database file were correctly written and parts not. And this is not really nice when you have 600 employees and they have to restart their application and it says, oh no, the database is no longer there. Especially not in the afternoon of 4 o'clock when all the day of 600 people is already lost because they had no backup, for example, multiple times a day. There are a lot of possibilities. We have set up a replicated environment for German Press Agency and for other customers. We hope to find the time to make a product out of it. Some of the people, like Michael, already were on a workshop in our company and he know already how to implement this on its own. It's more a kind of a transfer of knowledge and not so much a product out of a box. If you think about something like the IB replicator, from my perspective, it's not a good choice. I can give you a database definition and a sequence of SQL operations, and you will definitely have a stopped replication, and you cannot restart the application in that without any external help. So it's, in my point of view, not a real replication. It's only a part of copying data from different areas to other areas. Okay, we are almost ready for the lunch break. Any more questions?
Page size and so on. Can you talk about somewhere? Because we have 16,000 in Firebird 2.5. It is a good idea to use it.
I have good experience with 16K page size. I have no real reasons found that I should use a smaller page size, except Leo told me he's transferring the database file, almost empty database files from point-of-sale systems to a central system, and he copies the whole database file. And a database file with a larger page size, which has not so much data, is much larger than one with a smaller page size. But this is not such a big deal. An empty database with, I think, 4K page size is, 4K, 400K or so. And with 16K, you have about 1.5 megabyte already with an empty database. But this depends on a lot of issues what you want to do with it. We have no bad experience with larger page size, especially since Firebird 2.1. With Firebird 2.0, better take 8K. There were some bugs, which, as far as I know, already solved, but there were some problems in that time. Okay, I think it's time for lunch, and at whatever time you meet me, wherever, simply ask me whatever you want. There will be some changes in the afternoon program. I will try to set up the new program on the screen, and as far as I have, again, connection to the internet. Thank you.